This is the video about the application of the comparative method using deductive reasoning. As I said in video number 1, deductive reasoning is probably most closely associated with game theory. It's pretty important to define what I mean by game theory, particularly because this is step 1 of the deductive comparative method. What I mean by game theory is the study of strategic decision-making, where you make simplifying assumptions to set the parameters of your game, and you make predictions about outcomes that are products of players trying to maximize payoffs given the constraints of the game. So let's write that down. It's the study of strategic decision-making, where you make simplifying assumptions to set the parameters of your game. And then you make predictions about outcomes that are the product of players trying to maximize payoffs given their constraints. Oh my. Let's write constraints again. So in plain English, players are trying to get the best possible outcome for themselves, and they're limited in what they can do based off of the choices that they have available to them, and the choices that they have available to them in game theory are really going to be set by the simplifying assumptions that you make in step 1. You know, it's probably easier to have an intuitive understanding of the application of game theory to the comparative method if we do a couple of practice cases. I'm going to start with an explanation of the prisoner's dilemma, which is a decidedly non-political topic, and then we're going to talk about the possibility of a nuclear arms race. Comparative method with deduction. Most broadly, we start with theory and we move to observation. And this is in direct contrast to the comparative method using induction, where we start with observation and then we craft our theory. So theory first, observation second. I told you that it would be easiest. Prisoners. Easiest to understand game theory if we actually had an applied example. To that effect, let's start with what you would probably talk about in day 1 of any game theory class, which is the setup of the prisoner's dilemma. So here's our scenario. You have 2 friends that are partners in crime. Let's just call them Al and Bob. And Al and Bob are walking down Main Street and they see a Lamborghini dealership and they decide that it's a really good idea for them to steal a Lamborghini. So they do so. They get a little bit nervous after a while and they ditch the Lamborghini in a neighboring town, and they're so excited at the thrill of their crime that they start doing crazy things and disturbing the peace. Now, both Al and Bob are apprehended for, well, disturbing the peace, but the police are pretty sure that they stole a Lamborghini, as the owners of the Lamborghini dealership were had some sort of fuzzy black and white security video where they saw people vaguely matching the description of Al and Bob. So here is the setup for the prisoner's dilemma. Al and Bob stole a car and are arrested in a neighboring town for disturbing the peace. There are a variety of things that could happen. After they're apprehended and arrested, Al and Bob are each placed in a separate room in the police department. So we have 2 players in our game. And remember, Al and Bob are each going to try and get the best deal for themselves. We're going to say Al is player 1, and we're going to say Bob is player 2. Al and Bob have 2 choices each, or they have a choice of either cooperating with one another and keeping their mouths shut, or defecting on one another and ratting the other person out. What they choose to do is going to determine how long they spend in jail. So we're going to say there's 2 possible choices. You can either cooperate or defect, and there's 2 players. Al is player 1, Bob is player 2. You can either cooperate or defect. So cooperate is keep mouth shut. And defect is rat out partner. Okay, I'm going to put all of Al's payoffs on top of this line, and Bob's payoffs will just be in the black space. So if Al decides to keep his mouth shut and Bob decides to keep his mouth shut, the police only have enough evidence to put them away for misdemeanor disturbing the peace. So misdemeanors, well, actually we're going to talk about the difference between a misdemeanor and a felony towards the end of the semester, but suffice to say misdemeanors are crimes for which the maximum penalty is 2.5 years in prison. Let's say for this particular vague rioting in the town, each person, if they kept their mouth shut, would receive 1 year in prison. Now, if Al decided to keep his mouth shut, but Bob decided to rat his partner out and sort of make a deal with the police, Al would receive 10 years for Grand Theft Auto, and Bob would get away scot-free. Vice versa. If Al decided to rat out Bob, he would get away scot-free, and if Bob decided to keep his mouth shut, he would be the sucker and get 10 years in jail. If they both rat out the other, they each get 5 years in jail. Using this setup, we're going to predict what the most likely outcome is, given that we assume that both Al and Bob are rational actors and are going to try and maximize benefits to themselves. To that effect, we're going to do this thing called listing the rank order preferences of each player. So, what are the rank order preferences of player 1? What are the rank order preferences of player 2? So, Al's best possible case scenario is for him to rat out his friend, and for his friend to keep his mouth shut. That way he gets off with no penalty whatsoever. His second best case scenario is for them to both keep their mouth shut. So in the first best case scenario, he has 0 years in jail spent. In the second best case scenario, he only spends 1 year in jail. The third best case scenario is for both of them to rat each other out because he would spend 5 years in jail. And the absolute worst possible outcome for him would be to keep his mouth shut while his friend Bob ratted him out, in which case he would serve all 10 years and Bob would get away scot-free. Similarly, Bob has the same rank order preferences. And what I'm doing right now is just listing the best case scenario for both parties. All right. If you notice that no matter what the other side does, a player does better to defect. If the other side cooperates, he can either be in position 2 or position 1. He's always going to want to be in position 1. If the other side defects, he can either be in position 4 or position 3. He's always going to want to be in position 3 versus position 4. No matter what the other side does, his best case scenario involves defecting or ratting out his partner. The preferences in this particular game are symmetric. So for Bob, if Al cooperates with the police, he does better by defecting. And if Al defects, he does better by defecting and not being the patsy. We're going to predict that no matter what the other side does, because it's better to defect, they will both defect on one another. So prediction, both defect. This game happens to have this concept of a dominant strategy, that no matter what the other side does, you do better by defecting. That is the dominant strategy in this game. Dominant strategy. Wow, did not spell dominant right. Dominant strategy, defect. Okay, so this scenario is a made-up scenario. There's a lot of simplifying assumptions. It's very unlikely that it could happen. Let's, however, apply this same setup to the probability of whether or not two superpowers are going to get into an arms race. Let me give you the scenario. Oh, here we go. So say you are an advisor to Harry Truman in 1946, and you are trying to help him with his budget request that he's going to submit to the Congress. And you have to help him to game out whether or not he should invest heavily in nuclear arms. What you're going to do is you're going to assess units of power if you build nuclear weapons versus if you don't build nuclear weapons. In this scenario, there are two superpowers in the world, the US and the former Soviet Union, that in this case, in 1946, we're going to call the USSR. So there's two players in this game, and you are advisor to President Harry Truman, who is coming up with a budget request, and you are determining whether or not it would be wise to invest heavily in nuclear weapons. So you can either build nuclear weapons or not build nuclear weapons. And you are trying to game out what the USSR is going to do. So you are USA, and you are trying to game out what the USSR is going to do. Just like in the last scenario, I'm going to put player one's payoffs in the underline. Player two's payoffs are just going to be in the black space. In this case, we're going to say USA is player 1, USSR is player 2, and payoffs are going to be in terms of units of power as opposed to in terms of prison sentences. We're going to say cooperating is not building, and defecting is building. Okay. So if the US, oh my. Okay, so if the US decides to build nuclear weapons and the Soviet Union decides to build nuclear weapons, they essentially can be in a scenario where they're going to mutually assure one another's destruction, but nobody else has nuclear weapons, so they each have a lot of power. We're just going to say arbitrarily they have 13 power each. If the US builds nuclear weapons, but the USSR does not build nuclear weapons, the US would have 25 power, and the USSR would essentially be powerless and totally outclassed. So they would have 0 power. Vice versa, if the US decided not to build but the Soviet Union did, they would have 0 power and the USSR would have 25 power. And if both didn't build, because building is so expensive and because, when you deplete your resources, you become less powerful, other things being equal. Let's just say if they both didn't build, they would each have 15 units of power. Just like in the other game, let's talk about rank order preferences. The US would first like for them to build, but for the other side to not build. So defect, cooperate. Second would be for both to build. Third would be for both, second would be for both not to build. Third would be for both to build. And fourth would be to be the patsy. Again, this is the same setup that we did in the last game with slightly different parameters that are now political. Just like in the last game, we're going to make a prediction. No matter what the other side does, players do better to defect. What we're going to predict in this case is that there is indeed going to be a nuclear arms race, and what would be best for, I'm sorry about this, we're having some technical difficulties, what would be best for President Truman to do would be to solicit the Congress to spend a lot of money on nuclear weapons. Nuclear weapons. And an arms race. And so we say yes, predicting an arms race. Okay, so this is all step one to formulate a testable hypothesis. The USSR and USA will both build nuclear weapons. Now, say that you were in a situation where President Truman didn't want to spend billions of dollars on nuclear arming without any kind of proof that the USSR was in fact doing the rational thing and investing in their own nuclear program. Well, what you would have to do is what we do in the comparative method, which is to test our hypothesis or our intuitions against data that already exists in the real world. What we would probably do for step 3 is do something like look for seismic activity for evidence of a nuclear buildup. That, however, is beyond the scope of this video. Hopefully you have an intuition now of formulating hypothesis based off of this study of strategic decision making called game theory. This is the comparative method using deduction.